Do we have you?
There it is.
Well, anybody have a burning desire to start?
I could talk about your power issue you were talking about last time, if you want to hear about that.
Far away.
So if we go to this page, and let's see, how do I share my screen here? So if I pull up the, could I do that? Okay, I guess we'll do it like this. So here's the schematic for the teensy, and you said you're powering the teensy off your USB cable coming in here on the left, and you're also powering it from VN pin over here on the right, and that you're getting power from your RC servo, which is coming into here and powering the thing. But if you look at this, I don't really care for the way he built these boards, but on the USB connector on the side, if you plug in USB power, the 5 volts from that comes in here through a fuse to a signal called VUSB. And if you go look at, I think it was this one. So right here, this hole on the back is called VUSB, and then on the front, it comes through right here. So that pin is available to you. But if we go follow that some more, so after we get to that pin, it comes from this weird looking thing here, which turns out to be a jumper block. And that is on board. That's this thing right here. So if you want to, you can take a razor blade and cut that little trace in between there, and that'll isolate your USB power from the teensy power. And if we follow, then that goes right into your regulator and provides 3.3 volts to run your teensy. But also you get the VN pin, which comes in and also connects directly to that. So that VN is connected directly to USB power. So if you've got both of those connected, that means the two are going to fight each other. And apparently, if that's the way you're running it, it hasn't hurt anything yet, but you could run the risk of destroying your USB hub or your whatever's upstream for that. In your case, I think you've got a Raspberry Pi on there. And what I don't like is you go look at the, here's again, the teensy stuff. Here, let me post these other links. Just, I find it a little hard to find stuff on his website, but and I lost my chat window. How do I get that back? Well, I'll post those afterwards because I can't get my chat window. Anyway, you look at this and it says, here's your VN pin. See right here, this is the VUSB pin right there. Here's the VN pin. And he says 3.6 to 6 volts. But he didn't say anything about the fact that's also connected directly to your USB connection. So I don't like the fact that number one, he didn't put a diode between the USB and everything else. And number two, he implies you can hook up anything you want there without causing any problems. So I don't really care for that. So if we go back here to the schematic, what you could do is, if you cut this trace right there between those two, that means when you plug in the USB, it does not power your teensy. And it also means you're not going to be putting the signal back into your USB hub. You're not putting the voltage from your VN back into your USB. And then the other option is, if you cut this trace and then put a diode between VUSB and VN, that means if the USB is plugged in, the diode will allow the USB to power the teensy. And then over here on your VN, between your servo and your VN, put a diode. And that way, whichever one has the higher voltage will power the teensy. And that way you can turn off either side and it'll continue to run. And like down here, he's showing something else for his VBAT input. Apparently I think that's an input if you're running a real-time clock inside of this thing. It takes the voltage either from the VBAT input pin through a diode, or this is taking the 3.3 volts from the output of the regulator. So either, if you don't have a VBAT connected, it just takes 3.3 volts from the regulator and powers the internal real-time clock. Or if you put a battery on the outside, then if you turn everything off, this maintains, the diode says, okay, I'll take the higher voltage, which is the external one, and that powers your internal real-time clock. So that way you can just keep a battery on there, keep your real-time clock running all the time. So if you're to do, if you're to do that, you put your diode between the VUSB. Essentially, you want to put the diode right across this pad, but unless you've got like a surface mount diode, that would actually be pretty slick. Cut that trace and solder a surface mount diode across those two pads, because if you look at the board, those are really big pads. You could probably get a diode that would fit across there. Otherwise, it's this pad right here and this pad right here. If you just put a diode between those two, or if you've got the thing plugged into like a board or something, then on the back where your connectors are, you could solder a wire from there and then run it to either you can like solder the diode in here and then have a piece of wire and then plug it in the back of your board or whatever. But that's just various mechanical ways to get around that. But if you do that, if you put the diode on both of those, then you don't run the risk of the servo burning out your USB or your USB burning out your servo, which you could run into either one of those cases right now, or it's simply powering the thing when you don't want it to be. The main drawback to just simply cutting that jumper is that the TNC will run whenever your servo is powered up, but when you got the USB cable in, the USB cable is not going to power that. So it could be that if you're expecting when you first turn it on, the Raspberry Pi will go out and enumerate all the USB devices. Well, it's not going to see this one because it has no power. But then once you turn on the servo, then it will work. So there's just little implications like that. But if you want the TNC to run when either is there, which is what you have right now, but you also run the risk of burning something out by having the two supplies connected together. You could put the two diodes in to fix that. I don't know if any of that makes sense or not, but that was my observation here.
Thank you very much for taking time to look at that.
Now, it turns out if you go to something like a, do I have that one up here? At one point, I had a schematic up for the like the Arduino Nano, and I believe the Arduino Nano does have between their incoming power. I think they do have a diode that goes to the before the regulator, but then they also just have the wire going externally, so you've got a direct connection again. So even in that case, you should add an external diode if you're going to power it externally and still be able to walk up and plug in the USB to reprogram your TNC Nano. So at the bottom line is, anytime you're using any of these little controller boards, you got to go look to see how they actually did it and see if it makes sense or not. And the other things I had here, this is the 3.5, 3.6. This one, he put some diodes in there, but he still got the same problem with the VN pin. So the VN pin here on the right comes in and comes over here and still connects directly to his USB connection here. So I don't know why he's got those diodes in there. Maybe he was thinking that was going to solve his problem, but that's not what that's doing. So even on the 3.5 or 3.6, he says it's the same schematic for both of those. Right here he says it's schematic, he just put a different processor on depending on what type it is. And I thought, well, on the 4.1, he might have fixed that, the 4.0, the 4.1. So the 4.0, he's got that done just exactly like the 3.2. So again, if you want to isolate it, you got to cut that jumper, and then he's got some other stuff. I think this MOSFET is probably like reverse voltage protection. So if you look at it backwards, it doesn't blow out the entire board. But he doesn't have any isolation between VN and the USB again. Now on the 4.1, he keeps adding more parts to it, but it's basically done just like the 4.0. So again, the VN and the USB are tied directly together if you don't cut that jumper. And then on mine, I had that ST Micro eval board. Do I have one laying around? Oh, here's one laying right here. So I had this board, and this one has on one end, it's got the USB connector coming in that goes to the debug processor. And then it's got, between there, it's got a diode that goes to the regulator to run the whole thing. And then somewhere along the edge, one of these pins is I think they call it the 5-volt pin. So what I did, I've got a diode that comes into the board to, so my external little voltage regulator has a diode that isolates it. And then between the USB and the regulator here, there's a diode. So basically I'm doing the same thing. So again, you just got to look at your board and decide if that's going to work or not work. And these are the little issues that, everybody just assumes the sheet says, where's that thing I had? So this one, so on the 3.2, it says VN is 3.6 to 6 volts. I'm guessing all of his boards say that. Let's see, let's go this direction. So this one I think is the 3.5. It says the same thing, 3.6 to 6 volts. And this is probably the 4.1. No, that's 3.6. Here's the 4.0. And so all of his boards say the same thing. Well, this says 3.6 to 5.5 volts. For some reason, he's backed off a half a volt on that rating there. But again, he still doesn't tell you that's connected directly to the USB port. So my opinion, that's a problem, and you have to watch for these things.
Yeah, just so you know, you're not sharing if you thought you were.
Oh, yeah, let me.
You were earlier, just you stopped.
Yeah, I know. I purposely turned it off and forgot that I was going to talk about the end. So this is so on the 4.1, see again on the VN pin, he says 3.6 to 5.5 volts. And if you look at the next one, the 4.0, he again says the same thing, 3.6 to 5.5. And then the 3.6 is again, now he's back up to a 6 volts. So he apparently dropped at half a volt because apparently people were complaining it was blowing out something if they got too high a voltage on that. And then the 3.5, again, he says 3.6 to 6. And the 3.2 is where we started. So that's just something to be aware of when you hook these boards up, that, don't assume that they did the right thing when they designed any of these boards. So that's, I guess, unless there's any questions, that's all I have to say about that.
I'm, continue to be in awe. It's a little bit of a lesson in how to walk through a schematic. Not a little bit of a big lesson. I think for me, I need to figure out, like Matt has, he's got his startup sequence and he's using a relay, which is really cool. I need to figure out how to basically do that same thing. And then cut that jumper and put the diodes in there based on that. Because I will tell you, in the back of my head, I was thinking, ooh, the next time I pull that servo out, I might actually switch from the Teensy to, what did I think I got a $2 Nano, or at least to test the Nano to see if it was sufficiently fast enough for that. But that's awesome. That's fantastic feedback. And then Matt, you had spent some time on the GPS ODOM. Thank you for doing that. I haven't had a chance to dig into that yet. Hopefully this weekend we'll get a chance to do that. More or less, how many lines of code did you add, delete, update, change?
I just initialized heading, but it still might not be, just use it sort of as a guideline. There could be other problems in there.
Cool. Well, thanks for taking time as well on that. Let's see how far I can get with getting ODOM. I think I was going to pull up the milestone plan for me. I think if I just share here, share. You see my spreadsheet?
Yes.
Yeah, so I was the thought occurred to me that really what this is, or could be or should be, is I think what you've educated me on now is there is, get fix working, get Um, can't flipping. Heading working. I mean, all of that is I think what I had, well, where I'm at right now is make sure those two things are working and consistent, and then get that working. That's the way I'm thinking about it. And localization is sort of a big topic, and I want to break it down into those three things, because I definitely don't have ODOM working. Anyway, as you said before, there was multiple steps inside of that, and it's once again proving to be right.
Yeah, each step is sort of like a whole room. And so there's a whole new language and terms and messages and things like that.
So the other thing for me was I'm reaching across here to try to get this, see if I can pick it up. Oh my gosh. I got my voltage divider organized for my, I can't see it, but so there's my, put together the voltage divider to take in, I mean, in this case, I'm just using this 12-volt battery and getting that down to 3.3 volts, actually a little less, so that I can read it on the ESP, so I can monitor my battery voltage with that ESP. That's the only other little tidbit that I have been spending time on. That's when it's raining. Jonathan, what's going on in your world?
I made a bigger box. That's my news. My friend Paddy came round and he looked at my box and he says, "You're going to need a bigger box." I thought, "What do you mean? I put everything in this big box." And then he described probably, and if I try and figure it out a rat's nest of wire, I'm not going to have trouble. And I remembered what that box looked like, and I thought, oh, maybe I'll get a bigger box. Yeah, okay. So I'll show you. I got pictures of my bigger box.
I'm going to stop my video because your audio is breaking up. I don't know if it's my end or your end.
Oh dear. Box. It's a massive hammer drill power toolbox. It's the box as well. I think I don't think I'm going to mount it there. I think I'm going to mount it here. The nice thing is that when it turns, this doesn't. It is the component over here. It's closed, and then when I open it up, I can have two surfaces. So I put an Arduino in there to give you a sense of how huge my new box is. So that's going to be my electronics box, where I can have luxurious amounts of space to lay everything out. And the reason it took quite a lot of work is I had to cut all the internal molding out of it, and that ripped the holes. Oh, you can see one little tab; it was like stuck. So then I had to I used a soldering iron to melt in a load of little patches to fill those holes. But yeah, that's just about my only bit of progress, really. Except I also I got this speed controller. Can you see me? Am I sharing video?
We can see your video.
Yeah. Okay. Yeah. So I got this speed controller working with my motor. So now I need to be able to control that. Where did I put that? Yeah. Oh, yeah. I remember I was talking about this last week, wasn't I? So yeah, as Jeff thought, these two wires are the switch there, and then these three are for the potentiometer. And I've discovered that any of these three not connected to the board here stops it working. So it needs the whole voltage divider, and it measures 100 and about 115 kilo ohm resistance. So, but I've got my my little digital potentiometer microchip, which is a 100K. So I assume that's going to be the most accurate or the best way to replicate this. I was wondering if I could just get rid of this red wire completely because it's just putting out a voltage and feed in, you know, it's all 5-volt logic as well. So I thought I might be able to make a little digital to analog converter and then use the PWM outputs from the Arduino. And you know, if I feed in a volt to that line, then I can feed 4 into that line or whatever the balance is and change it that way and just use 2 pins. Which, yeah, I don't know if anyone's got any opinions on the best way to go for emulating this component. Whether I should just, I mean, I think I've already got my digital potentiometer, so I guess I might as well use that. Probably the best thing.
So when you have that hooked up and working, so if you've got it, so the potentiometer, you can turn it and the motor speed changes. If you hook your voltmeter up to the center lead of your potentiometer, does it, when the motor is stopped, you get 0 volts? When you turn it the other way, do you get 5 volts coming out that lead? Or do you see something else?
Do you mean when I'm measuring from this red one to the wiper?
Yes.
Yeah, it goes from 0 to 5 volts exactly.
Now, when you say if you don't have all three of them hooked,
when it's going really slowly, you get 5 volts coming out of the wiper and more or less 0 coming out of this black lead. And when you turn it all the way up, this one goes down, this one goes up, I think. I don't know.
And the supply voltage is 5 volts?
Yes. Yeah.
what do you, when you say you're measuring 5 volts, what reference are you using? Where is your black lead of your meter going?
Oh, I put
does it across the potentiometer, or did you have your ground lead hooked up somewhere else on your?
No, so I was putting the red lead on this red wire, which is the power going to the potentiometer, and then I was testing these 2 points, the wiper and the other side of the potentiometer, and that was supplying. Yeah, it was reading 0 to 5 volts from the red wire to the wiper, and then the balance of 5 volts from the red wire to the black wire.
Well, what I would do, I would assume that the black wire on the potentiometer is your ground. So you want to hook your black lead from your meter up to that, because you want to know your voltage with reference to ground. So then if you touch your red lead to your red lead, it should say 5 volts. And you touch the red lead to your wiper, that should give you a range. So as you turn it towards the slow speed, I assume it's going to get closer and closer to 0. As you turn it up, it's going to get closer to 5 volts. So the way you were doing, if you're measuring it with reference to the red lead, the 5 volts, that would be hard to duplicate if you're trying to put a signal in. So you want everything referenced to ground. So it's just a matter of how you look at it, basically.
Yeah. I probably got. I was probably measuring minus voltage and didn't notice the minus symbol or something. Yeah. So. Yeah. Anyways, I'll try and wire up that digital potentiometer.
So then you made the comment that if you have to have all 3 leads hooked up or it doesn't work at all. It could be that you don't need the black and the red connected to the potentiometer, that if you put in a valid value on what was the wiper, if you put a voltage in on that, it could be that it'll keep everybody happy. So if you generate a voltage, you also have to have a ground reference between your motor controller and your Arduino or whatever you're using. So you have to have, the ground's connected together on the 2, and then you're going to put the voltage into what was the wiper pin. And if it requires all 3 hooked up for some reason, it could be you could leave the potentiometer in there, but don't hook up the wiper and just feed the wiper voltage in from somewhere else. If it refuses to run, if you don't have the potentiometer in there. Does that make sense?
Yeah. I thought I tested that I disconnected the ground, and it just went immediately to full speed, regardless of where the potentiometer was.
Okay, that would indicate that you're putting a full 5 volts on it. If you disconnected the ground, you no longer have a voltage divider. So that means, yes, you would have had 5 volts on the wiper, and that would be full speed. So again, that's good. That indicates that this is going to work. So a few meetings back, I pointed out that if you have an Arduino and you're trying to create a PWM, or you're trying to create a voltage from that, you can't just hook it up to a pin and say use the PWM command or whatever, they pulse out or whatever they call it. You have to do that thing with the resistor and capacitor to convert that into an actual voltage. And I think I posted a link to a couple of websites that explain that.
Yeah. I read through them, and I can go back and reference the how to build a digital converter. I think that's what it.
So also when you
that might be easier.
Yeah, so when you try that, go ahead and set up your Arduino and put the external components to convert it into voltage, and just hook it up to your voltmeter, and then by putting out the different values, verify that you can get 0 volts to 5 volts coming out of that, and then you can hook it up to the motor controller and see what the motor controller thinks about that.
Cool, I'll do that.
I mean, other testing suggestions. For me, I always take it in small incremental steps, so I might literally take an Arduino and a servo, a radio control servo, and get that working so that I understood the basics, and had a simple program running to just sweep that back and forth. And then I might take your big motor controller and hook a small motor to it and see if you can get the Arduino to drive it. I don't know. I just break it down into small pieces and have small components that'll fit on a desk and get them to sort of work in principle. So I sort of understand the concepts before I then move to the, outside or onto your big machinery, and you've got big motors pushing a lot of voltage and whatnot.
Yeah, that's very wise. I tend to do it all at once and make no mistakes, and then ages trying to figure out.
Although the comment about hooking up an RC servo for testing, I'm not sure that the RC servo output command is the same thing you want to generate your 0 to 100% PWM command. So don't let that confuse you, if that, because a servo wants to see a 1 millisecond to 2 millisecond pulse width, but what you want to do, you want to go all the way from 0, PWM of 0, all the way up to a PWM of 100%. which I think on the Arduino they put out, I think the number goes from 0 to 255. So you write in a 255 and you should get the 5 volts, write in a 0, you should get 0 volts, and 128 should give you the 2.5 volts out of it. Whereas that's probably not how you run an RC servo, and I'm not sure. I think the RC servo, you might use a pulse out command to do that, where you can specify the width of the pulse. And I think it's just simply called analog out is what you want to do to get your, to inevitably generate your 0 to 5 volts. I think you want the analog out command or analog right or whatever they call that. Now, another thing to keep in mind, as I said, it goes from 0 to 255. You can run that and say, does that give you enough resolution? For running your big motors, that's probably going to be completely adequate. Otherwise, if you need to get more resolution than that, there's other ways you can set up the timers to generate higher resolution. So instead of having 0 to 255, you might have 0 to 2048 or something. So you get smaller steps on the speed. But for what you're doing, it probably won't matter. The 0 to 255 will probably be plenty adequate.
Yeah, I think so. Oh, I've got another question. Can I my friend Paddy was interested in getting involved in this community. Can I get my friend Paddy in here? He's much better engineer than I am. Yeah, he's quite keen on trying to write software for Rope and Rust.
Could you turn off your video and see if that helps your audio? Because your audio is breaking up quite badly. Unless you have something you have to display.
I have the same problem.
Is that a bit better?
Well, for the moment it is. We'll continue on and see how it works.
Can my friend Paddy was quite interested in joining this Slack community, and he's a much better engineer than I am. Can I get an invite sent to this guy?
Absolutely. He just needs to deposit his $3,000 entrance fee that Matt organizes, and then he can join right on up. Right, Matt?
That seems reasonable.
Either that or send him an email, one or the other. I think, Matt, you've got the control, don't you?
Yeah, we can, anybody sign up, shoot me his email, we can send him an invite.
Okay, I'll do that.
The audio definitely improved when the video was stopped.
Yeah, your audio is working quite well now.
Oh, good.
And sometimes, some days it works good and some days it doesn't. So that's just the way it goes with this modern technology.
Depends on the Welsh weather, I think. I've got when people were talking about their in the other meeting you have, people were talking about using remote computers to be able to do all their processing stuff. I've got an HP Z820. I had this idea, I could upgrade it and then everyone could use that to run their stuff. But then I realized that I have no, like, my internet is never going to be good enough for that. So, yeah, that's all my news.
I was looking to see if I had any code handy to show. Because I probably goofed it up, but so I don't think I can do it on this machine, but there's a folder out there. In the Ross Slack folder, in that folder, in research test code, And Jeff will probably point out why these are all incorrect, but and I'm not sure I can pull it open, and yeah, I can't. Oh yeah, this worked. So there, I've used this right microseconds, Jeff, before to get a servo to move.
Okay.
And then I would use I probably won't be able to find it quickly, but that analog statement you mentioned about 0 to 255, I've used that before as well. So, and probably there's some that are, there's probably a correct way and not a correct way. I'm just trying to see if, open with, what did I use? Text editor. Now this is going to use, this is, yeah, the right microseconds. Again, statement. I've been able, I think there's a couple of different ways I've been able to get servos to move using C before. And I mean, this is one that's I'm using in my current Teamsy. But anyway, don't blow anything up, Jonathan. Using a small motor that you don't care about and a motor controller that's not your primary one is a good way to start if you can. But finding the, do you have the spec sheet on your motor controller?
No, I've got an eBay listing. It's quite a cheap thing. Yeah, I could research it a bit more. It's a bigger one. Yeah, so I blew my first one up. Anyways, that's around somewhere. So yeah, this second one's a beefier one than the first one that I acquired. Yeah, this one doesn't seem to set fire to itself straight away.
Yeah, I definitely, for me anyway, the testing process is try to break it down into pieces, do it on whatever I can, small bits on the table, and then move it out to the bigger machine. But that's just mine. Call if you have questions or get stuck. Jeff, anything else going on in your world you want to comment on?
I see John Lee just posted something asking about why his wheels won't work, and I haven't responded yet. But my comment is, his problem is he's got too much friction for the amount of power that he's got, and there's several things that lead to that. Number one, he's got the little tiny motors, and I don't know what his power driver is. And he's got, it looked like he had 2 battery packs on there, so the more weight you add, the more friction you're going to have. But one of the quickest solutions is just take plain old electrical tape and wrap around your tires, because he's got some kind of rubber tires on the thing. But wrapping the electrical tape around, that cuts the friction down immensely. So that either that or just plain old, plain old cellophane tape. This happens to be the non-transparent stuff, and that, but it's like a shiny plastic stuff. Any of those putting on your tires, that'll reduce the friction. So for that little thing that he's got, that might help out. So I was gonna respond to him on that, but I haven't yet. In fact, here I made up a demo. I didn't have little wheels around. Here's a big wheel, and you simply wrap the tape around so it just simply covers the face of the wheel, and that should cut down the amount of friction you get. So if you try to drive on carpet or whatever, I think that'll help. And just something to keep in mind. And he's asking what's the appropriate ratio for the width to the length. And well, what it really comes down to is if you're going to run skid steer, you got to have lots of power to turn those wheels. And apparently the setup he's got doesn't have that for whatever reason. And I don't know if it's because his power driver isn't supplying enough power to the motors, or I assume that those motors, the way they're geared, is that basically the same motors you have, Matt, on your thing you're driving around?
Yep.
So, and yours seems to drive around okay?
It just has a dolly wheel in front, so I'm not dragging that wheel. So you can do the same thing. This is basically a skid steer, but crazy wheel in front.
And that's another thing you could do is either take off two of the motors and put a wheel on like that, or just simply raise it up and just have two of the wheels spinning, and that would help that too. So that didn't occur to me that he's got a different setup than what you have.
That thing you held up, what voltage does that run at, out of curiosity?
5 volts, just runs off of Raspberry Pi.
The motors, do you have a power pack though? Like a 8-volt power pack or something?
It just runs these batteries.
So four AA's?
Yep.
I noticed that a conversation about the skid steer thing, and I was thinking, Matt suggested he make it narrower. I was thinking if he didn't have enough space on there, the other thing he could do is make it significantly wider, which would be quite funny. would help.
Actually, I think making it wider would improve his immediate problem, because the wider you get it, it just thinks it has 2 wheels instead of 4 wheels. But without modifying its frame, I'm just thinking that, reducing the friction on the tires would be the quickest thing to do. And that's just a quick test, wrap some tape around there and see what that does. And I don't know what he's got for a motor driver. I'm assuming whatever he ordered this kit, he got some kind of a driver with it. And whether that's meant to drive a single motor, because he's got the motors in parallel that he wired up. So that's taking twice as much current for that. He did make the comment that his motor's like 6 volts with 4.9 amps. And I don't know, is that something he's measuring or what his battery produces, or I didn't know where that came from. It seems like if you're pushing 5 amps through one of those little motors, seems like something's wrong, but I don't know.
That does sound like a lot of amps for a small motor anyway. Anything else, Jeff?
I keep meaning to play with that gyroscope that I've got, and while we're sitting here, I started wiring up my circuit on the board here, because when I hooked it up, sure enough, I put power on it, and I had to put 12 volts instead of 5 because it's got an internal regulator, and I can put it on the table, hook up to a voltmeter, and sure enough, at no turning, there's 2.5 volts. Turn it one way, the number goes up. Turn it the other way, the number goes down. So I hooked it up to my Arduino Nano because it's a 5-volt processor, and that worked just fine. I could get values out. I think I was showing last time I was showing some of the values I was getting out of it. So then I hooked it up to a Teensy. And at one point I was saying that, well, if you look hard enough, there's a library for the Teensy to give you 16-bit A to D. So I thought, well, the first thing I'll do is track that down. So I found the guy's page on that, and he says, before you start, make sure you load the latest Arduino IDE code for the Teensy. So I loaded that up, and it turns out as soon as you load that, you've got the new A to D stuff. So all you got to do is go in and tell your A to D, do you want it to be 10 bits or 12 bits or 16 bits? And there's all kinds of other options that I haven't looked at yet, as far as sampling speed and conversion speed, and somewhere you can even set it up for a differential input. There's some extra pins on the, here, let me pull this up again. Share screen. So on the Teensy, it turns out you have to use pin A10 and A11 to get differential input, and they're not the normal pins. There's some extra pins in the middle here. So these 3 pins right here, one of them is a reference, and I don't know if it's a reference input or output, and then there's A10 and A11, and you can also use A12 and A13, and those you have to get off the back here or there. So this square pad here and this square pad, so you'd have to solder wires on the back to get A12 and A13 on that. And it turns out if I run the differential input, because this A to D converter has, it's going to show up, and get it right way up. So it says, the top says +5 volts, and it says out, and it says VREF. And VREF is just simply half of the 5 volts. So it puts out a constant 2.5 volts. So if you take the output and the reference and measure those with the differential A to D, it looks like the noise went way down. And I don't know how long it would take me to pull this up, but it looks like, so it looked like it's getting like 3 counts of noise as opposed to like 50 counts of noise that I was normally getting reading it. And but the problem is I see 3 distinct levels, but it's changing like 130 counts between each one of those. So I don't know if it's just simply that for some reason in the differential mode, it's not as high a resolution. So I need to look at that more. So then I thought, okay, well, my biggest problem was it's thinking it's putting out 0 to 5 volts, and it's a 3.3 volt A to D input. So I got to reduce that down. So I hooked up, just grabbed some resistors, made a voltage divider, but that drags down the output of the gyroscope. So what I'm doing now, I'm trying to put a buffer in between there. You hook up just put an op amp in between there to buffer what's coming out of it, and that'll give me a low impedance load, and then I can put any voltage divider I want on the output of that. And I was just too lazy to hook all this stuff up, so that's what I'm trying to do right now. Well, the other thing I noticed was I think I originally showed the counts coming out hooked up to an Arduino Nano, and I was only getting like 3 counts of noise coming out of the thing, so it seemed pretty stable. And then I switched over to Teensy, and I went through the 10-bit, 12-bit, and 16-bit, and by the time I got up to the 16-bit, it looked quite noisy. What time is it? As I'm talking here, I'll try to pull up the plots of that. So I tried to pull up, where's one that says 2.5. Pull up this one. I could complain about the Open Office Calc, but I won't. I'm glad it's free and that it works. So here's, let's see, share screen.
Have you found a bug in its
No, it's just
capability?
simply that, number one, I pull it up if I've got too many values that I don't want to display and keeps crashing. And since I got dual screen running, if I say something like, here, let me just give you an example. I just say, click this and say plot. And I don't know if this will even show up or not, but we'll see what it does. Can you see this window that's asking me what type I want? Oh, it's not gonna. Can you see this window, or is it not even showing up? It might not show up. It shows up halfway on one screen and halfway on the other screen, no matter where I put my stuff. Since I
We're seeing the right half.
Okay, well, it always shows up like that. So I have to go to one screen or the other to do it. So then I have to drag it back in like this and then select what I want. So just little things like that tend to annoy me. And,
Now we saw the whole thing, but it went away.
Yeah, but just things like that. No matter where I start this up, whichever screen I started on, when I go to do a graph, it puts that halfway between the 2 screens. That just annoys me. So anyway, this is my, I think specifically this is what I was measuring, the 2.5 volts. And let me see if I can get the other one without wasting too much of everybody's time. Here's just a random plot. Oh. So this is just a random plot of the actual signal coming off the gyroscope. And I thought, well, it seems awful noisy. And if you look here, there's like 650, there's at least 50 counts of just garbage on there all the time. And then it sometimes is like 100 counts. Now that's out of 65,000 counts. So it's not a whole lot on there, but I thought, well, obviously the gyroscope is putting out noise. So then what I did, I connected that 2.5 volt reference, and I'm getting the same kind of noise on that. So that tells me that it's actually the Teensy itself, something in the conversion chain. And it turns out it's for the voltage reference to make the A to D work. It's tied to the, let's see, how can I do that without wasting too much time here? Where did it go? This one. If I go back to this one, see, how do I, here, I'll just, rather than trying to figure out how to share the screen, I'll drag it back over here. What was I talking about? The A to D reference. So here's your A to D reference over here. What they've done for the,
It's just you're still on the calc screen.
oh, so I gotta do, let's do this, stop sharing, share this one. Okay, can you see that one?
Yep,
Can you see the schematic?
Yep.
Yes. Micro USB or USB micro dash AB. 3.2.
Well, you're supposed to be this TNC 3.2 schematic. Is that what you see?
Yep. 3.2.
Okay.
Yep.
So on the reference for the A to D over here, this tells it what kind of range, what's the top number going to be. What they've done, they've just tied that back through the reference high here, through a 470 ohm resistor, back through the 3.3 volt, the 3.3 volt signal that's running the processor. They do have a couple of ferrites in here to try to isolate it. But my thought was it could be that just that reference is noisy. So since the 2.5 volts and the 2.5 volts I'm reading in and the signal from the gyroscope both basically look the same way, I'm thinking it's just the A to D converter isn't working right. So then I tried, and this, I suppose this isn't going to show up either. Let me try it. Diff. And you probably can't see the new screen on that. Let me do this. Share screen. Screen one. Can you see screen now that's not here? Let me
Back to an open office calc within a chart, and choose a chart type.
So this time when I opened it, it showed up not on halfway across the screen. So anyway, come on. And also the little buttons are too small to grab a hold of, so I waste half my time trying to play with those. Come on. And let's see, unfortunately I gotta go through, say 0 to 800, we'll grab. That should be enough. And if I say plot that and say I want it to be a line, say finish. Well, now it doesn't look as good as I wanted. But see, this is like the maximum here goes from like 420 to 440. Well, now it doesn't look as bad as it did. This supposedly is the differential input. So I'm feeding the 2.5 volts into one and the gyroscope signal in the other, and I'm getting a lot better signal coming out of the thing. And I don't know, but I thought when I was looking at it before that these were really big numbers here, and just from one point to the other, it seemed like it was 100 and some counts, but now it's not doing that. I'm only getting like 20 counts maximum here. So now that I look at this, that's very encouraging. The fact that if I just hook it up the differential, I can make that work. So anyway, my problem was I needed to feed in both of those signals into the differential inputs. I couldn't do the 0 to 5 volt. I had to do 0 to 3.3 volt. But then when I added the voltage divider on, it loaded the thing down to the point where it was screwing up my signals. So then I'm going to put that op-amp buffer in between, so they're both buffered with a nice low impedance output, and then try the whole thing again. So now that I look at that, that's giving me more hope that this is going to work. But then I said, okay, I get a good enough signal, so I went back and tried to say, how can I do what I really need to do? And I don't have a plot of that. But what you have to do is you have to say, take the baseline. Let me bring that back up. See, what you need to do, you have to figure out the averages and say at zero movement, what's my average number? So you just go through and say, when you start it up, average like 100 values or something. And in this case, it looks like 430 is about the average value. So then what you do is you take the 430 and every sample, you subtract that from it. So it says 0. And then once you start the loop, you say, each time you take a new sample, you add that in, you just integrate that value in. So you just keep adding that each time. And as long as you're not moving, it stays at 0. And you start rotating, say, to the left, the number might be getting bigger. If you rotate the right, the number will get smaller. And that way now it's tracking your actual angle. So instead of giving you the rotation rate, it's giving you an angle out of it. And then when you're all done with that, you go through a calibration step and you say, with it at 0, you turn it 90 degrees and you get a number like 535,000 or something. So you divide that by the 90 degrees, give you counts per degree. So now you have a scale factor. So now you can put it on the table, you can turn it back and forth. And you go to 0 and it says 0, you go to 90, it says 90. But my problem has always been on every gyroscope, if I go back and forth a few times, the thing gives me kind of a step function where each time it creeps. So it starts off here at 0, and I go to 90, and I come back to 0. It either goes less than 0 or more than 0. And I do it again, and each time it kind of steps and just gets further each time I do that. I haven't figured out why it's doing that. So I don't know if there's a bias as say clockwise as opposed to counterclockwise. Every once in a while people talk about the rotation of the Earth being a problem. Well, I don't think these are sensitive enough for that, but for some reason, at every gyroscope I've played with so far, if I turn it back and forth several times, it just seems to creep each time I do that. And that's the one thing I need to figure out eventually, because that's what always stops me right there. So no matter how clean I get the signal, and no matter how little drift I get in, if it's just sitting there, if I can't get the signals to work after that, then it won't do me any good. So that's kind of where I'm at right now. It's just trying to get this gyroscope wired up again and get a nice clean signal out of it. And then I put the extra 2 or 3 lines of code to convert the actual rate into an angle. So it's just a matter of just playing with it, I guess. And then I was digging through a box looking for my old Melexis gyroscope, which is one of the first ones I started with. And it was a single axis gyroscope. And I was thinking it had an analog output, but it turns out it had a built-in A to D. I think it was like an 11-bit converter or something. So it was back in the old days before they had modern stuff. And I was fairly happy with that, and I did a lot of experiments. So looking for that one, I found another box, and I found one, I think they're Epson gyroscopes. And I think those are some kind of a crystal tuning fork. And I'm sure I didn't pay $75 a piece for those, because I got a bag of 5 or 6. And I probably paid closer to $5 or $10 a piece for those. And then I've got an old gyration gyroscope, which is in a big metal, it's like in a metal cube, about 1-inch metal cube. That was, they originally designed it, and they said, oh, you could use it for like a mouse, so an arrow mouse. So you hold it up like this, and you go like this, and you're supposed to control the mouse, your mouse pointer on the screen. And then I've got some other ones that I've got, when I dig, I've got all these little things that I've bought, just like everybody else. I buy it on eBay, try it, and throw it in a box. I got all this crap that I could hook it all up at the same time and see what it's all doing. So that's kind of where I'm headed right now.
I haven't ever tried, but has anybody ever tried to get the gyroscope signal out of a phone?
No. It would be interesting to know how stable that is coming out of there, but no, I've never tried that.
I mean,
I'm doing some stuff with the Androids, but I haven't really tapped into the internal sensors like that. It's more the camera type thing, but I eventually plan on using that type of thing, and so I'm interested in how accurate that is also.
Based on your previous conversation, though, Jeff, I always thought gyroscopes were just inherently, I mean, the inexpensive ones, if you will, were just inherently good for a short duration of time, and then you had to sort of reset it. Is that not true? You're hoping it'll like sit there all day and not.
Well, the longer I can get it to sit there and not drift is good. And then the fact that once I start using it, if I get consistent values is the next problem, trying to get that out of it. But like the thing in your phone, yes, that's going to be a cheap gyroscope, and then they're going to throw some fancy software at it. So depending what they used, it may or may not be better than just buying a module off eBay and hooking it up and playing with it yourself. So
one thing with the Android, it uses the other sensors like the magnetometers, whatnot, to correct for that drift or detect when it should be reset automatically, or not automatically, but kind of, we got to get integrated sensor suite. And so for, handling drift, how accurate it's going to be from one position to another is yet to be seen, I think. But I'm hopeful that'll be good enough.
And the biggest problem with trying to use a gyroscope and correct for it, it turns out that yes, a gyroscope does drift, but you can use your pitch and roll from your accelerometer to correct and say my pitch and roll from my accelerometer are stable because you keep correcting against the accelerometer. But when you do the yaw, the rotation, you don't have anything to correct against except for everybody tries to use the magnetic field, the magnetic north. So if you know where magnetic north is, you can correct your yaw on that. But as Matt points out on his magnetometer, when he drives past the big metal stuff, it does really stupid things to you. So you have to figure out, then you have to get into the fancy mathematics and say, well, do we ignore that or not ignore that? And so I'm just trying to get down to the point. I just want to get the cleanest signal I can out of a gyroscope and then worry about it after that. And I bought this one, this automotive one, because it did say it had a crystal tuning fork as opposed to the little silicon MEMS, the cheap little ones. And when I was digging through my box, I found those Epson ones. I think those were something fancier too than just the cheap little MEMS sensors. So it's going to be interesting to compare all this stuff and see what works and what doesn't work and try to figure out where the problems are on that.
And then there's still the fiber optic one for $300 you told us about.
Well, they've still got those for sale, but they're $400, I think, with $20 shipping.
Okay.
It could be if I just write to the guy and say, what's the format to make them work? He might just tell me, and then I might be tempted to waste $400 on something from Israel to see if it's going to work. Of course, it doesn't work in the long run for everybody else. You know, they're not mass producible, or they are mass producible, but they get a lot of money for them.
Anything else, Jeff?
That's all I can think of.
Matt, anything?
All good. More fun.
Oh, come on, man. You always have interesting things you're messing around with.
New localization bots. If you're playing around with localization, sometimes I like to add a camera. So if you're recording a Ross bag and you're driving around and a year happens, the camera helps to understand what's going on inside of the bag, but bag file. If you're recording logs.
I mean, is that just a raw video image, or are you doing, what do they call it, visual odometry or visual? Yeah, that's what they say.
Yep.
Visual odometry?
Yeah, but I also like just to record a camera so you can see what was going on while you're testing.
Are you recording straight video, or are you taking like frames, like once a second or something? I just wonder
15 frames a second.
It just seems like I can chew up your storage very quickly doing that. So if you get it down to the point, you just say, you know, take it once a second or something, you still get a lot of information so you can tell where you are as you drive around.
Yeah. So you can just record the compressed topic, and it's a lot less data. So like if you're messing around, like if I'm messing around with odometry, I just go for a drive or go for a walk, and then I see if the camera is turning left, what is odometry doing in RViz? Just things like that are helpful.
Yeah, it does look like it's not displaying at 15 frames per second. So something's throwing out data as you go. I don't know what it would be doing that, but.
This is a program I use called Peak, and it just basically makes a GIF, animated GIF out of a video. So it's very lightweight, and it's sampling. But
possibly even on the camera driver, you can specify how many frames per second, and you could slow it down there too, and that might, number one, cut down on the bandwidth of all the topics going by, and then if you're trying to record it, are you recording it to like a flash drive on your Raspberry Pi or somewhere else?
Just on
just right to the SD flash?
Yep.
Because I went to the trouble of getting an external SSD drive and plugging it into my Raspberry Pi, and that works. It works and seems to work great, but in playing around trying to get the UDEV rules set up so I could name the drive something reasonable. Now, if I don't have that drive plugged in, I try to boot it up, it stops at the boot process because I can't find that drive. It'll just sit there forever. So that, I don't know why it's doing that, but so that can be a problem. If I forget to plug it back in or whatever, and then it won't power up and I don't know why. And if oh yeah, I got to plug that drive back in. So there's just little things like that, all these little things that add up could be a real pain trying to get this stuff to work.
Absolutely.
Were you manually steering, or was that programmatically steering in that?
No, I'm just walking around. I just hold it in my hand and walk around.
Cool. Anything else, Matt?
Nope.
Doug? Can't really tell what background you got turned on today.
Oh, it's this Blake 7 BBC background that guy from the local robot club demoed last week, and so I thought it looked kind of neat. But anyways, I haven't done too much with the robots this week. A lot of maintenance, and it's the Tuesday meeting is out cutting hay and fixed plug in the fuel line on the lawn tractor. That's running again. Thorn got down in there in the line, and my brother blew out the radiator hose on the loader tractor last night, so now I get to go and fix that. So keep busy though.
Doesn't sound like a robot job.
Well, maybe eventually you just gotta have your equipment operating first before you're automated. So very tangentially, you're accurate.
Right. I tell myself if I could just get one screw in every day, or one little something every day, just make.
I did come across a couple interesting tidbits. I think from Elon Musk, he was talking about LiDAR, and apparently they don't use LiDAR in the Teslas. He says two cheap cameras on either side of the vehicle do it just as good a job as any LiDAR that they found, which I thought was interesting.
That's all they're using.
Well, they probably aren't using cheap cameras, but he didn't think much of LiDAR in general, I guess. I mean, his comment. The other more practical thing is I found that Firefox, there's now a standard for inputting a game joystick controller into a browser page. There's some interface stuff for that. It's now available, which is encouraging to me because my main interface that I've been trying to work with is, be able to control the robot over any web browser. And so if I could control it, have the web page taking in a gamepad controller, it lends itself to testing things out and controlling the robot manually if need be. And so that's a new thing that I came across. I didn't know they had implemented before. So that's gonna be handy. I haven't done anything with it yet. So that's what I've been looking at.
Cool. Well, it looks like we overshot our time here. Anybody for any other last minute comments, questions, thoughts, secrets? Jonathan, any more oven baked, or what was it? Pizza outdoor oven things?
No. I'm gonna go and see my aunt. We're gonna have a socially distanced walk. That's my weekend.
Well, tell her the Robot Club said hello.
All right. See you next week, everyone.
Bye, guys.
Bye.